Hey guys, welcome back. I know I played a cruel trick on you last week. I said we were going to do tasks A and B, and then we only did task A, but I didn't want that episode to go too long, and so I thought actually task B and C, which we're going to cover today, would fit together a little bit nicer, make for a little bit more manageable episode length. So that's what we're going to be covering today: aircraft flight instruments and navigation equipment, as well as instrument flight deck check. Instrument flight deck check. So anyway, for those of you who don't know me, I'm Sam Terrell, the Northwest Aeronaut on YouTube, and I want to thank you all for joining me today. Hey, if you're watching on YouTube, please do me a favor. Hit that subscribe button right down below. It really helps this channel grow. And if you like this episode, if you get something out of it, I'd also appreciate you hitting that like button. It helps spread the word and get the channel to grow, which is always my goal. I want to help as many people out there as possible. All right, we're going to be diving into Task B of Area of Operations 2 on our ACS breakdown for you instrument pilot candidates out there. This is aircraft flight instruments and navigation equipment. Our objective is to determine the applicant exhibits satisfactory knowledge, risk management, and skills associated with managing instruments appropriate for an IFR flight. All right, knowledge section, it says the applicant demonstrates understanding of operation of the aircraft's applicable flight instrument systems, including pedostatic instrument system and associated instruments, gyroscopic, electric, or vacuum instrument system and associated instruments. C, electrical systems, electronic flight instrument displays like your PFD or MFD, transponder, and automatic dependent surveillance broadcast, ADS-B to most of us out there. Also, magnetic compass and operation of the aircraft's applicable navigation systems, which we'll get into more in a second. But let's go back to the top here. Pedostatic instrument system and associated instruments. Now, for most of you out there, this should be Private Pilot 101 stuff. What instruments does your pedostatic system feed information to? All right. So we have three primary instruments that our pedostatic system works with. We have our airspeed indicator, our altimeter, and our vertical speed indicator. Okay. Our pedostatic system is comprised of two parts, the pedo tube and the static port or the static system. So here's the first question you got to ask yourself or be able to answer. Which of those three instruments that I named utilize the pedo tube? The answer is only the airspeed indicator. Only the airspeed indicator utilizes the pedo tube. That gives us the ram air from the oncoming airstream, and it compares it to the information from the static port or the static air in order to give you an indicated airspeed. But the altimeter and the vertical speed indicator only use the static information from the static port. All right, next line item says the gyroscopic, electric, or vacuum instrument systems and associated instruments. So, gyroscopic instruments. What instruments in your aircraft are gyroscopic? Well, generally we have three, okay? We have the attitude indicator, we have the heading indicator, and we have the rate of turn indicator or your turn coordinator, all right? Those are the three gyroscopic instruments. Now, those gyroscopic instruments could be powered in usually one of two ways, and that's what it kind of alludes to next. It says electric or vacuum, right? And those are kind of the two ways our gyroscopic instruments are powered. They're either powered through electricity, like your turn coordinator generally is, okay, or your rate of turn indicator, or they're vacuumed, or they're powered by the vacuum system, such as any older panel. You know, we're kind of getting away from vacuum systems in general, and that's not a bad thing in general, but the vacuum system traditionally was comprised of a vacuum pump, sometimes two vacuum pumps, especially in multi-engine aircraft, but a vacuum pump run by the engine, which powered your attitude indicator and your heading indicator. Nowadays, we got things like G5s, Garmin G5s, and fancy things like that, which removes the need for vacuum system, which is great because vacuum systems are notorious for failing. And so having the redundancy of an electronic gyro system for those instruments, the attitude and the heading indicator, along with the fact that they are separate redundant systems, usually, one electric G5 for the attitude and another G5 for the heading, makes for much safer flight overall, especially when you're in IMC. So that kind of takes us to the next line item, which is electrical systems, electronic flight instrument displays like your PFD, MFD, and transponder and ADS-B broadcasts. Now, it's important to understand that if you have a G5, like for your attitude indicator, that's essentially a PFD, and you kind of need to know not only where that G5 is getting information from, but how is it processing it? Because we no longer have a vacuum system. So how does a G5 know which way is up? Well, first of all, you have to understand the G5 gets its information from several different sensors, some of which being things we just talked about, like the pitot-static system. So, of course, that's going to be connected to the G5 to give it altitude and airspeed information. But it's also going to get information from an attached GPS. It has internal sensors called MEMS, gyroscopes, and accelerometers. Okay, so basically they are accelerometers and gyroscopes that instead of working off of a vacuum system, they work by sending electronic impulses and are the same type of devices you have in your phone so that your phone knows which way is up and all those things. So MEMS, accelerometers, and gyroscopes. You also have magnetic information being fed to it by a magnetometer. That magnetometer is generally kept in the wing, away from all the other electronic stuff that might interfere with it. Sometimes it's kept in the tail, depending on the aircraft. All right, so you want to know where the G5s or whatever digital display unit, whether it's a G1000 or whatever, where it's getting all the information from. As I always say, it's not enough to know how something works. We also need to know how it breaks. And when it comes to digital displays, whether you have a G1000, G3X, G5, doesn't matter, you need to know what happens when something breaks. Usually these systems have reversionary modes. G1000, it'll just switch displays and put all of your primary flight information on your multifunction display. There's also the button there that you could put it into reversionary mode manually, okay? So you need to know what happens when something breaks. You need to know how it breaks and, of course, what to do when it breaks to handle that situation. All right? Now, let's talk about the magnetic compass. The magnetic compass, we kind of take for granted these days. We don't really pay much attention to it, but as an instrument pilot, we still need to kind of know how to use a wet compass and specifically the errors involved with flying on a wet compass. So you might be familiar with the acronyms UNOs and ANDs, which describes some of the errors we deal with when doing turns in reference to the compass. So UNO stands for undershoot north, overshoot south. This is the acronym we use to know how to deal with the leading and lagging tendencies of a wet compass when we're doing churns. So when we churn to a northerly heading, the compass lags. So in other words, we need to undershoot north. So if we're trying to turn to a heading of, say, 360, we might stop that turn when the compass says 330. Because when we roll out on that heading of 330, the compass will eventually catch up and show us the proper heading, which is probably going to be closer to 360. Now, when we're turning to a southerly heading, the overshoot south is because the compass leads. It shows a heading ahead of where we actually are, so we need to overshoot it. If we're trying to turn to 180, let's say we're making a right turn to 180, we might turn until that says 200 or 210, because again, when we roll out on that heading, the compass will eventually come back to what you're actually on and show something around 180. Okay, so UNOS, and then the ANDS acronym stands for accelerate north, decelerate south. So when we are on an east or west heading, if we were to accelerate, let's say facing west, that compass is initially going to show a turn to the north. We need to be aware of that because we can't allow that to give us a false sense of us turning. Remember, this is supposed to be a situation where we're in IMC trying to follow a heading based on that compass. So we know if we add throttle and start accelerating, we're going to expect to see a turn to the north. We need to disregard that and understand that we're probably not turning. We don't want to try to turn to the left to counter it, because then we'd actually be turning off of our desired heading. Same thing if we decelerate. If we slow down on an east or west heading, it's going to initially show a turn to the south, so we need to be aware of that. So if you haven't done compass turns with your CFI out there, go ahead and practice them. I encourage you to do it. It's really cool and interesting to actually see it in practice rather than just talking about it in theory. All right, moving on, it says operations of the aircraft's applicable navigation systems, including very high frequency, omnidirectional range, or VOR, distance measuring equipment, also known as DME, instrument landing system, ILS, marker beacon, receiver and indicators, and area navigation, RNAV, global positioning system, GPS, wide area augmentation system, WAS, and flight management system, FMS, as well as autopilot. All right, lots to unpack here, guys. Let's go ahead and go back to the beginning where it talks about VOR. I've got a couple different videos on VORs and some shorts, so if you haven't seen on the YouTube channel yet those videos, I encourage you to check them out. There is videos on how to use VOR, and then there's some shorts that talk about things that generally don't get discussed when we are teaching VORs these days, things like declination. Okay, declination is a big thing to kind of be aware of. If you were actually plotting a course the old way on paper while using VORs, declination is one of the things that you would want to account for. Okay, so I got videos on that. But VOR in general, you need to know how to dial in a course to the station. You need to know how to dial in a course away from the station. Understanding that a radial goes away from the station, a bearing goes to the station. Okay? Some people get into the details of how a VOR actually works, like how it sends out radio waves and how those radio waves are received by your aircraft to know where you are relative to it. You don't really have to dive into that. I don't know of a single DP that's going to ask you those questions, like how it actually physically works. You need to know how you use it, how you'd use it in your airplane, okay, and how obviously to use the radios that interface with it. Distance measuring equipment. So this is an interesting one these days because most airplanes these days, we don't have DME equipment on our aircraft. These days, most DME functionality is taken care of by our GPS. So here's a quick question. I'm going to pull up the approach plate for McMinnville. This is KMMV. I'm going to pull up the procedure for the approach, the ILS 22 into McMinnville. Now, keep in mind, this is an ILS or localizer approach to runway 22. In the notes section, it says, DME required. When local altimeter setting not received, use Aurora State altimeter, and talks about increasing the DA and all that. So my question to you, this is, again, an ILS or localizer approach. My question to you, my question to my students is, if our GPS was not working, could we fly this approach? Well, this is not a GPS approach. It doesn't say GPS is required, nor should it. I mean, an ILS is a separate system, right? However, it says right there at the beginning of the notes section, DME required. And our aircraft, as I'm sure probably very similar to your aircrafts, we don't have DME outside of our GPS. So if our GPS was down, if it was inoperable, we could not fly this approach, even though it's an ILS approach. All right. So that's something to be aware of. DME these days, we don't generally have separate units that take care of that. And if it's built into your GPS, then essentially what an approach like this is saying is that you need to have an operable GPS. All right. All right. Let's keep going here. Marker beacon, receivers, and indicators. So marker beacons these days, at least in the US, have more or less gone the way of the dodo, if you know what I mean. Okay. The outer marker is something we talk about. You'll still see it on a couple approaches around the country. The outer marker, all you really have to know is what type of indication it would make in the cockpit, if you get one at all, which is a little blue flashing light with an O in it. Okay. Generally, the outer marker coincides with the final approach fix of an approach. Not always, but generally that's what it marks. Okay. And there's, of course, also the middle marker and the inner marker, and we won't get into those in the podcast today. It's good to have just a general understanding of what these markers do or were used for, or might still are used for somewhere in the country. But I doubt you're going to get many questions on the check ride about it. Not to say that you shouldn't be familiar with it. Okay. Area navigation, RNAV. Okay, RNAV, area navigation. This is obviously a big one. This is kind of the mainstream form of navigation we use these days. GPS base, okay, which is kind of our next one. We talk about GPS base, and that's one thing to understand is that all GPS is a form of area navigation, or RNAV, but not all RNAV is GPS. Okay, so they're not interchangeable. Okay, there was RNAV navigation even before GPS came along, but these days we primarily use it in the form of GPS. And so you want to make sure you know things like, is your GPS even IFR approved or capable? Because not all GPSs are created equal. Okay, so you need to know what your GPS is approved for. And as with everything, we need to know how it works, how it breaks. All right. Wide area augmentation system. This is something to supplement GPS, right? This is what allows us to fly precision type approaches on an RNAV approach down to like LPV minimums and gives us that vertical guidance. So, of course, you need to know what WAS stands for, wide area augmentation system, but you also need to have a general idea of how it works. Okay. What the different parts of the GPS system are. Basically, we have control, we have space, and we have the user. Okay. And how WAS basically has ground control stations that augment the signals from the satellites and correct those signals to make sure that you are receiving the most accurate information. So just have a general idea of what WAS is and how it works. And then lastly, it says Flight Management System here, FMS. That's something that we don't really have in the GA world explicitly, not like we do in the airlines in the Part 135 and 121, where they actually have a flight management system. However, we do have GPSs that we load our flight plans in, we load approaches in, and departures and arrivals. The GPS is essentially a flight management system for our intents and purposes. So you need to be familiar with how that works. And if you're using one of the mainstream GPS units, like the Garmin GTN 650 or 750, very popular these days, there's a great simulator that you can download on your iPad, and you can play around with it. It is very thorough and will go a long way in helping you become proficient in the use of that GPS. All right. All right. And then lastly, it says use of an electronic flight bag, or EFB, if used. And guys, this sounds kind of silly maybe the way it's written, but so many of us today, we have our iPads with ForeFlight or Garmin Pilot, but mostly just ForeFlight. And one of the biggest downfalls is people showing up with everything in ForeFlight and not understanding how to use it fully or even remotely proficiently sometimes. Okay. But understanding too that, actually, let's put that off. We're getting into the risk management stuff here. So this is kind of a good segue. Risk management, it says the applicant is able to identify, assess, and mitigate risk associated with monitoring and management of automated systems. So we just talked about the autopilot, right? What's the number one rule? And what's the number one rule? Okay. Go back and watch that if you don't remember. Okay. But that's basically risk management for autopilot and automated systems. Difference between approved and non-approved navigation devices. That's what I was just referring to. Knowing if your GPS is approved, not just for IFR flight, but for what kinds of IFR flight. Okay. Do you have WAS? Are you able to do an LPV approach, or are you going to be limited to a more non-precision LNAV approach? Okay. Depending on your unit, the more modern units, they're going to have all the bells and whistles. But if you have an older unit, like a 430 or a 530, you may or may not have WAS. Okay. So knowing what type of approval your device has. Modes of flight and navigation instruments, including failure conditions. This goes back to what I just was talking about. You need to know how everything works, and you need to know how everything breaks and what to do when it does break. Okay. All right. And then this was the segue: use of an electronic flight bag. So not only do people show up with ForeFlight and maybe not know how to use it, but when it comes to risk management, if your whole world is in this iPad, as far as everything you need from approach plates to charts to performance numbers to whatever, your flight plan, what happens when this goes away? What happens when this iPad dies? The battery dies. What happens when it overheats? Okay. People always say, oh, I got extra batteries. I got a battery pack. I got my cable I can plug into the airplane USB here. Battery is never a problem. I'm good to go. That's not going to fix it from overheating. Okay. And for those of you in warm climates or just anybody out there in the summertime, you'll know it's not uncommon. These things get hot and they just shut down. You could be at full battery power. They'll just shut down. So what are you going to do, and what backups are you going to have to mitigate the risks associated with using an electronic device like an iPad that can fail in a number of different ways? Having a backup iPad or your phone is one thing to consider, but maybe even better yet, having copies of the paper charts and approach plates that you're using for a given trip, even better. Okay. All right. Then use of navigation databases. So part of our pre-flight checks needs to be always making sure that our databases are up to date. These are not just the databases in the plane. Of course, that's probably most important, making sure the GPS database is up to date, but also the database and the charts and approach plates in your EFB. That's part of your just pre-flight maintenance and planning, is making sure you have up-to-date approach plates. Okay. All right. Finally, guys, the skills associated with this section, it's really just says operate and manage installed instruments and navigation equipment. So know how to use the stuff in your plane. And then operate and manage an applicant supplied EFB, iPad, if used, right? So again, if you show up with an iPad, you need to know how to use it, and you need to demonstrate that you know how to use it. Okay. So pretty straightforward as far as the skills there. Pretty much covers everything we just spoke about. All right, guys, moving on to task C, instrument flight deck check. It says the applicant, this is the knowledge section. The applicant demonstrates understanding of purpose of performing an instrument flight deck check and how to detect possible defects, IFR airworthiness, including aircraft inspection requirements and required equipment for IFR flight, required procedures, documentation, and limitations of flying with inoperative equipment. All right, so what's the purpose of performing an instrument flight deck check? Well, It's to make sure everything works, right? How do we do this? Well, we got our taxi checks that we do. Well, actually, before that, when we start up the GPS, it's going to come up and it's going to come up with a check to make sure that it's communicating properly with your other flight instruments, like your G5s. This is extremely important, and you need to make sure you're not skipping it. Okay, usually it's something like vertical CDI half up, lateral CDI half left, OBS 150, desired track 150, no flags, annunciators on, things like that. But you need to make sure they're communicating properly. Otherwise, you're just not going to get the right indications on your G5 where you're expecting them to be. Now, as we get further along into our taxi, we want to make sure that all of our other flight instruments are working. So whether you are just naturally doing some turns when you're taxiing, or if you've got a long straightaway, you could even do just slight little S turns. And we want to check and make sure all the instruments are behaving as we expect. Airspeed should generally be 0. Attitude indicator should be staying level. Your altitude should be more or less not moving. Your vertical speed should not be moving. Your heading indicator should turn appropriately with your heading as you turn. And your rate of turn indicator should show a bank. The little airplane should be banking in the direction you're turning. And then the ball should be swinging to the outside of the turn. So if you are turning to the right, the ball should be swinging to the left. Okay? So those are our kind of instrument flight deck checks that we do during startup and taxi, and we want to make sure we are doing those so we don't have any nasty surprises once we get into the air, only to find something doesn't work. IFR airworthiness, including aircraft inspection requirements. So we all know our Aviates acronym, and if you don't, you should go back and listen to my podcast episode on aviation acronyms. But Aviates, that's our annual. Our VOR inspection, our 100-hour as required. Our ADs, or airworthiness directives, are, what comes after that? I can't spell. T, transponder, okay? Transponder every 24 calendar months. E, ELT, every 12 months. And S for static system. So which ones of those are specific to IFR flying? Well, the static system and altimeter is specific to IFR. That needs to be done every 24 calendar months. So it may not be required for VFR flight, but it's required for IFR. Okay, and usually it's done with the transponder. Okay, and then of course the VOR check. The VOR, we're talking about basically our nav radio. We're not just talking about the VOR itself, but the nav radio. And we test it against the VOR, either with an in-air check or a ground check. Okay, and there's different types. You want to know the types of VOR checks, whether it's a dual receiver check, a VOT check, okay, or an in-air check. Know the degrees to which it can be inaccurate. Okay, how much deviation can it show and still be considered passable? Usually it's just 4 degrees on the ground, okay, plus or minus 4 degrees on the ground, plus or minus 6 degrees in the air. But that VOR check is something that not many VFR pilots do or remember to even look at. So as an IFR pilot, you need to make sure it's done and recorded properly, okay? All right, let's see here. We've got required equipment for IFR flight. So, of course, we know our tomato flames. That's our daytime required equipment as per 91205. We have our FLAPS acronym, which is our nighttime VFR required equipment. And for IFR, again, this is only pertaining to 91205. There could be other things as dictated by your type certificate data sheet or any supplements, any STCs, okay, that would tell you a certain piece of equipment is required to be in operation. But as far as 91205 goes, we can use the acronym GRAB card. GRAB card for our required IFR equipment. G is going to be a generator or source of power. Okay. R going to be radios specific to the route of flight to be flown. Okay? A is altimeter. A sensitive altimeter. What's the difference between the sensitive altimeter and an altimeter that's required for VFR flight? Well, if you ever go looking like a Piper Cub and look at their altimeter, you'll notice it looks a little different. The hands on the altimeter aren't all the same. We have hands basically that show altitude in thousands of feet. So when the big hand goes to the 1, it's not 100 feet like you're used to seeing in our IFR equipped aircraft. It's 1,000 feet. Okay, so every number is 1,000 feet. It's not very specific or very exact. So it needs to be a sensitive altimeter with that's of course adjustable with a Colesman window. B is ball. Ball being our slip skid indicator, okay, and our turn coordinator. C is a clock. Okay, you need to have a built-in clock with minutes and seconds in the aircraft. Okay. The other A is attitude indicator. You need to have the attitude indicator. Some people might be surprised to know you don't need an attitude indicator for VFR. When I say, well, why would you? An attitude indicator is just a artificial horizon. Why do you need an artificial horizon when you've got a real horizon right out the window, right? So that's only required for IFR flight. Our next R is our rate of turn indicator. That's the other part of your turn coordinator. And then finally, D is your DG, or your directional gyro. Okay, your directional gyro, your heading indicator there, that is required for IFR flight. All right, so that's your required equipment. And again, that's only as it pertains to 91-205. There may be other things that you'll need to know about specific to your aircraft. All right. Then it says required procedures, documentation, and limitations of flying with inoperative equipment. So same types of things we look at in IFR as we do with VFR as far as a legal stance. Okay, we're going to be looking is it required by an MEL, a minimum equipment list? Is it required by your type certificate data sheet? Is it required by 91-205? Okay, or is it simply required by you? Is it just something that you don't feel comfortable flying without, whatever that is? Okay, maybe your VOR, your nav radio, your nav 2 radio, maybe you have two, but maybe your nav 2 radio is out and it's properly placarded and deactivated and all that stuff, but maybe you don't feel confident flying without a second nav radio. Okay, that's a perfectly valid reason for a no-go decision. All right, next, risk management. It says the applicant is able to identify, assess, and mitigate risks associated with operating with inoperative equipment. Okay, so that's kind of just what we talked about. It's not just about whether something's required legally, but is it required for safety? I mean, is it required for your personal minimums? If you are not comfortable flying without a nav 2 radio, then you don't go fly, right? That's a personal minimums thing. And it's something that you want to be aware of, okay? Because maybe you have certain procedures or a certain way you do things and a certain way you're used to doing things that requires a second nav radio. And when that second nav radio is not there, you may not even realize it until the moment comes where you're like, well, usually I do it here. And now what do I do? Okay? So you need to be able to identify and assess the risks associated with having that inoperative equipment, even if you're legal to do so. And then it talks about operating with outdated navigation publications or databases. So bottom line is, guys, if you're flying IFR, your databases must be up to date. Not just, of course, the GPS database and your in-aircraft databases, but your EFB, okay, for flight. You need to make sure you have updated plates and all that. You also need to, even if everything is up to date, it's always important to compare what a GPS is showing you. Like when you load an approach into that GPS, you need to be able to compare what the GPS is showing as far as waypoints and the order of those waypoints and maybe associated altitudes with what you're seeing on the approach plate in front of you. Make sure they match. Okay? All right, guys, finally, the skills section. It simply says perform pre-flight inspection by following the checklists appropriate to the aircraft and determine if the aircraft is in a condition for safe instrument flight. Pretty straightforward. Okay? I'm checking for those required equipment. We're checking for those required inspections and airworthiness, general airworthiness things, okay? And then making the go, no-go decision based off that. And just remember, there's always two sides to this coin. There's what's legal and what's safe. Those two things don't always line up exactly, okay? So just because something's legal doesn't mean it's going to be safe or safe for you, all right? All right, guys, so that was task B and C of Area Operation 2. Hey, really appreciate you joining me today. If you enjoyed this and you're watching on YouTube, I'd appreciate it if you hit that subscribe button down below and hit that like button. It really helps grow the channel and get the word out there to others who will hopefully find this useful as well. We'll be back next week with our next installment of our ACS breakdown for you instrument pilots. And we will see you next time on Centerline.